Hello guys, I hope y'all are doing okay today. In this video, we will discuss something known as the intermediate value theorem. Okay. Notice that I kind of already highlighted this. This is typically almost guaranteed to be on the AP exam, guys. Okay. So first of all, let's go ahead and start out with a definition, and then we'll kind of dissect on what this means. Okay. So here's what it says: if a function is continuous, and I made a video about continuity, so if you have not watched it, make sure that you watch it. You should already know by this point what it means to be continuous. But let me go ahead and continue. If a function is continuous on a closed interval from a to b, okay, and f of a does not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in the interval from a to b such that f of c is equal to k. All right, sometimes, reading math definitions can be a little difficult, so let's go ahead and try to dissect this with a diagram, okay? So first of all, this definition says we gotta have a continuous function, so which I drew here on purple. I mean, it is obvious that it is continuous, okay? We have a closed interval from a to b, so here's a, here's b. So if I actually go ahead and draw this on the graph, so here is a interval, so with dotted lines, from a to b. So we've got a closed interval there. Okay, then it says f of a cannot equal to f of b. Well, f of a would be up here, and then f of b is down here in my case, so we can definitely see that f of a and f of b are not the same. Okay, let's say, and k is a number between f of a and f of b. Well, f of a and f of b, f of a and f of b, guys, are y values. So when I look at the y values, f of b is right here, right? F of a is right here. Well, k is in between, okay? Here's the key part. Then there must be at least one. So at least, there could be multiple, okay? But at least one location, and we're going to call that number C. So it has to be one location between A and B. So in this case, look, I called it C right here, in which if you plug that in, you get K. So if you plug C into the function, you should get K. Okay? That's really what the intermediate value theorem says. In other words, guys, because this function is continuous, okay, there must at least be one value here such that it hits every single value between f of a and f of b. Think about it. There must be at least one x value that if you plug it in, you're gonna get every single value between f of a and f of b because it is continuous. It's in the middle. It's called the intermediate value theorem. So all the intermediate values, or the middle values, have to have an input. Okay? That's all the intermediate value theorem is saying. It's just a fancy way of saying that. Okay? So let's try an example. Okay? One way that we can use the intermediate value theorem is to locate where the zeros of a functions are at. Okay? So here's the instructions. It says use IVT, which is shorthand for intermediate value theorem, to show that f has a 0 on the interval between 0 and 1. Okay? So this is just one way to use it. Okay? I'm not saying that this is the way to use the intermediate value theorem, but it is a way to use it. So it says, once again, we're going to use the intermediate value theorem to show that this function, which is down here, has a 0 between 0 and 1. Okay? So, first of all, here's our function. We have x to the third plus 2x minus 1. Is that continuous? Well, if you go back to your algebra 2 knowledge, okay, this would be a polynomial, and one of the requirements in order to be a polynomial is that you are continuous. So therefore, this is a continuous function. Okay, so in order to apply the intermediate value theorem says, remember, so we got to have a closed interval between a and b, which in this case is going to be 0 and 1. F of a cannot equal to f of b. So in this case, we got f of 0. If I plug in 0, I get a negative 1. And if I plug in 1, I get a 2. Therefore, since f of 0 does not equal to f of 1, we can't apply the intermediate value theorem. Okay? So in other words, you have to check whether or not the intermediate value theorem would work, which I've already did check the two things. It is continuous, and f of a does not equal to f of b. Okay? So here's where you have to get creative and how to use it. Now think this through. For f of 0, I got -1. For f of 1, I got 2. Now, -1, it's obviously a negative number, and 2 is a positive number. So think this through. If at f of 0 you're at -1, and at f of 1 you're at +2, and you are continuous, then that means that in order for me to connect from -1 to 2, I must at least cross the x-axis one time, which would then guarantee to have at least 1 0. So, because that's true by the intermediate value theorem, there must be at least one value c. So this doesn't help you find what value it is. It just tells you that you have a value such that f of c would equal to 0. Okay, so that is one way that we can use the intermediate value theorem. That is typically what your textbook, especially if you use a Larson textbook, will ask you to use it for. All right, here's our next and last example for this video. It says, verify that the intermediate value theorem applies to the indicated interval and find the value c guaranteed by the theorem. Okay, this one has an extra step. So not only does it apply, but this time is like, hey, find what that c value is. Okay, so remember, the intermediate value theorem does not find the value. You have to go out and find it. Okay, so here's our function. We have x to the third power minus x squared plus x minus 2. On the interval from 0 to 3, yes, that's a 3. Looks terrible, but that is a 3. Such that f of c equals to 4. So if it does apply, we want to find out what that c value would be. Okay, so what do we got to do? First, we got to check if this is continuous. Okay, one more time, we have a polynomial. Polynomials are continuous, so we should be good to go. Secondly, we need to figure out what f of 0 is and f of 3 is. They must be different in order for this to work. So we're going to go ahead and show that work here. So it is continuous from 0 to 3. Okay. F of 0, if we plug in 0, we get -2. If we plug in 3, we're going to get 19. I know that I'm not showing the step, guys, but I'm more than confident that you can do that basic algebra. Okay. Therefore, we can, since f of 0 and f of 3 do not equal to each other, then the intermediate value theorem does apply, which means then that there should be a value in which f of c equals to 4. We just need to figure out what that is. Well, actually, yep, okay, so here we go. Since 4, which is an output, does fall between -2 and 19, right? There must be at least one number c such that f of c equals to 4. So how are we going to figure this out? Okay, so think this through, and this is a little bit tougher problem, so it requires a little more thought on your part from like algebra. Okay, what do you guys think? Okay, well, I gave you a minute to think, so let's go ahead and show you what I attempted. Okay, well, in order for this to work, right, if there is such a c value, I'm going to have to plug it into this equation, right? And the answer that it shoots out should be 4. So what I'm going to do is actually, I'm going to solve this by setting it equal to 0. Right, so I'm going to subtract the 4 and set it equal to 0. And I'm going to use something called the rational zero test. So for those of you that are not familiar with the rational zero test, I would encourage you to look for my video on the rational zero test so you know how to apply it. But I'll give you kind of the gist of how it works here. Okay. So first I'm going to try in this case to see if these factors, I will attempt grouping, but grouping will not work for this scenario. All I can factor out of this would be an x, which would be x squared, which would leave me with an x minus 1. But that would not happen here, therefore factoring by grouping would not work. So the rational zero test seems like a good choice. So the way that it works is we take all the factors of 6, which in this case are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now the reason why I say plus or minus is because you can multiply two negatives to get, a positive and a negative to get the -6, right? And a combination of these numbers would achieve that, okay? Well, technically, I didn't show that. You find all the factors of the constant and you divide it by the factors of the leading coefficient, which in this case is a 1. So if I divide by plus or minus 1. So your possibilities in this case would be 1 divided by 1, which is 1, 2 divided by 1, which is 2, 3 divided by 1, which is 3, 6 divided by 1, which is 6, and the same thing with the negative, right? So all of those are possibilities. Now, to check whether or not those are actual zeros, I'm going to use division. Okay? Now, I obviously tried this to make this video shorter so you this is takes sometimes just some practice, some luck. Okay, so I tried the 2, so I'm going to use synthetic division. So remember, the way synthetic division works is that you get rid of the variables here and you only use the coefficients in front. So instead of an x to the third, I have a 1, and x squared I have a -1, and x I have a 1, and I have -6. Now I'm going to try all my possibilities here, or if I get lucky I can just try 1. Okay, so we're going to pretend I got lucky and I tried 2. So if I try 2, remember, for synthetic to work, you take the first number and you just drop it. You take that number and you multiply it by this number here that you're trying to divide by. So 1 times 2 is 2, and you put the result here. Unlike normal division, you, instead of subtracting, you're going to add. So 2 plus -1 is 1. So you take that number and then you multiply by the 2 once again. So 1 times 2 gives you 2. You add the 2 numbers, so I get 3. 3 times 2 is 6. You add the 2 numbers and I get 0. The fact that you got 0 means that this actually doesn't have a remainder, which means that it divides evenly. So what happens after you divide? Think about it. If you were on a third power and you divide, that brings you down to an x squared. So what happens here is that this 1 represents the x squared, this is the x power, and to the first power, I'm sorry, and then this would be no power. So really what happened is, by you finding out that you got the remainder of 0, you found out that 2 is a factor, which means if you write it as a factor, it would be written as x minus 2. Now this would be x squared plus x plus 3, which is what I wrote down here. Okay? So now at this point, it's like, okay, I can continue to try to factor this, but it should be obvious to you that there is nothing that multiplies to be a 3, that adds up to be a 1. Therefore, this is the most factoring you're going to get out of that. But it is going to be obvious that if you set that equal to 0, c equals to 2. So what would happen here? If I go back to this step and I plug in 2, that's 2 to the third power, which is 8. 2 squared, which is 4. 8 minus 4 is 4. Plus 2 is 6. Minus 6 is 0. But if you go back to this step, it should answer the question which we have. But you really don't have to, because this is a step that you took in order to solve for this. So if you got this value here and it worked here, then it should work also here. But we'll go ahead and try it. 2 to the third power is 8. Minus 4 is 4. Plus 2 is 6. And minus 2 is 4. Therefore, we have successfully proven that the intermediate value theorem does apply to this indicated interval. And we found out that the c value that would make that true would have to be 2. Hopefully this video helped you understand what the intermediate value theorem is and how you can apply it. So thank you for watching, and I'll see you next time.